What's up, everybody? It's Jump Scared, and today I have something that I think is pretty cool. This is the periodic table, and I have got all the elements in here. I bought it, and now it's finally here. So, there is a ton of stuff on here that can be toxic or cancer causing, so they're sealed inside this thing. It looks a lot like glass, feels a lot like plastic. And, wait, this thing's upside down, I just realized. Sorry. So, I've got a bunch of stuff I like a lot. So, like, for example, the gases. Like, helium is inside a bubble. Same thing for nitrogen and oxygen. Same thing also for fluorine, chlorine, neon, argon, krypton, xenon, or even hydrogen, which is up there. But radon and oganesson are also gases, but they're extremely radioactive and are extremely unstable. I mean, you can collect radon, it's just you can't collect oganesson. All the elements from 100 to 118 are ones that you cannot buy. They can only be made inside laboratories and are extremely unstable. Like take darmstadtium, for example. That's element 110, and that can only last for only 14 seconds. And that's the most stable isotope of it. It's called darmstadtium-281, and it shares similar properties to platinum, palladium, and nickel. But that's probably what makes it kind of like, that probably means that it's magnetic or something. I don't know. But we also got technetium, that is radioactive, and there's no technetium on here. Same thing for promethium. But the only radioactive ones we got are thorium and uranium. But those can last for billions of years. We also got the alkali metals. Lithium, sodium, potassium, rubidium, and cesium. But francium is an alkali metal, except it lasts 22 minutes. But some of the rare ones include gold, or even, let's see. Yep, platinum's one of them too. So it means darmstadtium and röntgenium can be considered some of them. But we also got magnesium. That one's pretty light. And alkaline earth metals are on that section, including calcium, strontium, barium, and beryllium, or even magnesium. But radium's one of them, but it's millions of times more radioactive than uranium. And uranium's safe compared to all these. Well, one thing I'm confused about is how mercury is red. Because usually it can be like, you know, it can be silver, not like the element silver, but like the silver color. And that's how it looks in thermometers, but except the other element that's liquid at room temperature is bromine, and you can see it's yellow because the vapor is yellow. Or maybe not, but I know the vapor is yellow. But we even got the smelling elements, including sulfur, selenium, tellurium, and livermorium. But there's no livermorium or polonium, because those are radioactive. Because I heard that sulfur smells like rotten eggs, and selenium smells like rotten garlic, and tellurium just smells like regular garlic. So those elements have a familiar scent to them. We also got some of the most toxic ones, including phosphorus, arsenic, and antimony. Well, white phosphorus can be cut with a knife, but except it appears to be soft, but it's not. It will also start smoking, and it's not only that, but if you light it on fire, you can't put it out. So do not buy white phosphorus at all. But arsenic is mainly just like a poison. I don't know much about it, but it's pretty poisonous. It's about the same as antimony, which is right below it. The SB comes from its Latin name, stibium. Kind of sounds like a skibby. But I'm not Gen Alpha, so I don't have to worry. Or do I? No. I'm not binge watching Skibby Toilet like those kids are. We also got some of the other ones that are toxic for inhaling, like zinc, gallium, oh no, not gallium, or cadmium, or mercury. And, oh, sorry. And then, we've got some of them that are kind of soft, such as aluminum, gallium, or indium. Aluminum, I don't know about, but I don't know if it's soft or not, but I'm pretty sure it is. But I know gallium can be cut with a knife. Same thing for indium, but thallium, I'm not sure. It's next to lead, so probably it can. We also got some of the rare ones, including rhodium, or iridium, or even osmium. And osmium is much rarer than gold is. So I think I have that. We also got tungsten, and I've got a cube of it right here. This stuff is pretty heavy, and it weighs over a pound. So watch what happens when I drop it. It shakes the bed. Because it's so sharp, I can just scratch my hand with it. That's why I drew a W on the box it came in. This is definitely a W. A W in this actually stands for Wolfram, which is the German name. In German, it's pronounced Wolfram. But it's really hard to crush this. It requires 100,000 grams of pressure to move this an inch. This cube's an inch, though. Anyway, back to the table. So, we even got the lanthanides, and this includes lanthanum, or even cerium, and these elements just are considered rare earth metals, and same thing for praseodymium or neodymium. This is used for magnets. But we've got promethium, there's nothing there, and for obvious reasons. And we've got samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, and lutetium. But I'm starting to think that terbium, erbium, ytterbium, and yttrium are the only elements that are useless because they're named after the same exact place, just with different letter combinations. That just makes no sense at all. But the actinides are below it. This includes actinium, thorium, protactinium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, einsteinium, fermium, mendelevium, nobelium, and lawrencium. Most of these have been extracted. I don't know, there's nothing there. Only ones that are there are thorium and uranium. And we also got iron right there. It's pretty dense. It shares similar properties to ruthenium and osmium. And just in case it's true, hastium is pretty dense too. But this makes me kind of think that potassium is denser than osmium. Except it's extremely radioactive. And there's nothing there. I'm also thinking seaborgium is dense too. Because you got chromium and molybdenum, or tungsten. Those can like shatter when crushed with a hydraulic press, I think. They're really hard, I think. I know tungsten is pretty heavy, and same thing for chromium, but I don't know much about molybdenum. But seaborgium, I'm sure, shares similar properties to them. And in fact, those elements are just like unstable, and we don't know much about them. So that's basically why I'm talking about them. So we also got silicon. That's a metalloid, which is a combination between a metal and a non-metal. It includes boron, germanium, arsenic, antimony, tellurium, and polonium. And the non-metals are hydrogen, which is up there, nitrogen, oxygen, phosphorus, or carbon, or even sulfur, or selenium. Those are the non-metals. But I'm thinking, like people have been selling carbon cubes on the internet, and they're like, I call them metals. They're clearly a non-metal. What's wrong with you guys? No offense, though. But for the most common metals, we got tin, like tin cans, or tin foil. We even got titanium right there, or even iron, which obviously I showed you, or cobalt, nickel, copper, and zinc. Those are pretty common too. Even silver, or platinum, or gold, or mercury, or something like that, because mercury is used for thermometers. I think that's why it has that red color. But the thing is, you can't see the ruthenium. It's, I don't know why. But it's pretty cool. I guess we got niobium that I think replaces gold. And we've got potassium used in bananas. And we got sodium, in which case sodium chloride is for salt, that kind of stuff. But if you're being asked to write the formula for sodium hypobromite, you're just gonna have to go with it when someone says, nah, bro. Because the formula is literally, nah, bro. Because it's sodium, bromine, and an oxygen. I don't know much about chemistry though, because I haven't learned it yet. I'm trying to do it though, but I'm doing it on my own. I haven't done I really haven't done experiments yet. But I don't know what these dots are for strontium and barium. But why is strontium SR instead of ST? And also, why is plutonium PU instead of PL? Like, literally, they don't. Did they seriously thought? Did they seriously thought platinum was PL instead of PT? Well, I also heard that you can chew indium like gum, but I really don't recommend it. Just don't do it. And gallium also melts in your hand. It can be a bit messy though, so wear gloves while doing it. You should always wear a mask when handling things like mercury or bromine, because they let off vapor that you can breathe in, and that can be fatal. And anyways, that is it. I hope you liked my elements. And I'll see you next to another video. Goodbye, everybody.